Hello, welcome back to the stream. I am Junchan, and we are back working on some of our streaming tools ideas with Haskell and GStreamer. And last time we got pretty far, or at least maybe the time before that, we got to finally get one of our pipelines to actually work, be able to trigger it from Haskell, and we had a list of things we wanted to look at in our log. Actually, I should do a little bit of my usual housekeeping there. We are March 20th, and I'll copy the streaming log as well. And yeah, what we had in our log was we wanted to try and understand why. Hold on. I copied an older version. Let me actually update this here. Okay, yes. Yeah, we walked through the documentation and played with some other examples, trying to understand the low-level API a little bit better. And also look at how to use tracing. And so one of the things I wanted to try and do is try to understand why the pipeline sent an end of stream signal. That was a little bit unexpected. So let me go back to this, because I believe I had some cabal run command right here, and right, I need to go into the environment first. And I think we got to see that it was the decode bin3 element that was actually signaling end of stream at some particular moment. But I'm thinking today, just in the interest of trying to get a little bit further ahead, that maybe we won't stop and try and dig down deeper into this until we really need to. So I think if I search here, we'll just touch base with where we were at, but not necessarily go further than that. So let's see. It was message EOS, right here, message type EOS, and we made sure that our code listed which where is it, here, that when we get a warning, we made sure to list the name of the message source, and that in our case here, it is decode bin3 that's sending this message type EOS. So we don't know exactly why, but for now, let's just say that at least we've observed that decode bin3 sends an EOS signal or message. Maybe we could search for that. It could be that this is something that's known. Decode bin3 sends end of stream. Block state change when one stream ends before the what does end of stream means? That might not be GStreamer. Let's make sure. Send NOS on old pads. Oh, okay. We might want to take a look at that. And stream selection. Yeah, the fact that this that decode bin is creating pads dynamically, and that in fact we had to take care of that in our code by using this event handler here, that basically is triggered when a dynamic pad is created. In our case, in the decode bin element here. And we were able to register that event handler with on element pad added. So it could very well be that, actually, can we dynamic pad created? We do send some logging output. Let's see how far these things are. Dynamic pad, they're not very far, right? The dynamic pad gets created here. And then not so far later, we get that warning there of an end of stream. So could it be that, and in fact, we have two dynamic pads created, in fact, like right after the other, one after the other, because we have, I think, a audio pad and a video pad. Yeah, that's right. Here we have the H.264. So, so I'm not sure about whether this is properly sequenced, because this is multi-threaded, so it could be that the print commands might not necessarily be all in the actual order in which they occur if they happen in different threads. But here we can see that we have the H.264 codec and the AAC codec that seems to be reacting to the pad creation, which I think is the downstream pad, is the video convert. I believe. I'm not 100% sure whether it's whether decode bin itself is actually hosting a DEC element, or whether that's the video convert downstream that contains that. Given how this is, I would think actually it is probably within the video convert, simply because the next element that sends the message is already the sync. Sorry about that. I'm going to take a very tiny break to put on another couple of layers. It's colder than I thought. I'll be right back. All right, so yeah, so my intuition here is that the decode bin, once its downstream pads are added, connects to video convert, which are these AV deck, H.264 and AAC, and that those then connect to the auto video sync. But I could be wrong. You know, I'm actually probably wrong, because look, video convert right here. So probably AV deck and AV deck, H.264 and AAC are actually in the decode bin and dynamically added in that sense. I'm a little bit curious about using. Oh, that might not have been the best choice, because now I'm confused about which one is the actual name and which one. The factory name is the first one. Okay, so I think we can call this decoder. And we run. So I think I did try this with the decode bin, which I think is just an earlier version. it does work. And what about EOS? It's type, right? Message type. Yeah. Yeah, no, it doesn't occur. It doesn't look like. We do get dynamic path created, but this time around we do not get the EOS. So it might be a quirk of the decode bin 3. So let's double check that this is the case by first of all, and not getting all these messages. Second of all, actually dealing with an end-of-stream message type by quitting, which was the original code, and then recompiling this. Yeah, it does work. So I think it's quirk of decode bin 3. So I don't think we need to dig into this more. I will just report this into our little. So decode bin sends an EOS message, but not decode bin. Decode bin 3, but not decode bin. So I think that's enough. We understand it enough that it's a quirk of one particular element and not a feature of our code or anything like that. Okay, great. So now let's look at dynamically changing an element property like file source location with the imperative API. So that's just a little exercise just to continue getting our bearings here. And I suppose what we could try is, for instance, so I think we have several .mp4 files in this folder, in the videos folder. If I have 1, 2, we could just alternate between 1 mp4 and 2 mp4, although we wouldn't be able to tell, I think, the difference because those are actually copies of the same file. Just an artifact of how I think the OBS, Streamlabs OBS exported our scenes. So maybe not the, well, yeah, no, probably not the best. I think I should probably try and do something like just manually open sample mkv in the middle of whatever is playing. Or they're just the reverse. Actually, maybe the reverse is even better since I actually have the path right here. So let's do that. Let's make it so that, for instance, where the question would be when. So I suppose now this gets us into some interesting territory because we need to take account for time passing. So that seems like maybe that would be connected to the main loop, or some signal. So let's take a look at the API maybe to figure this out. Sorry, give me a second. Okay, so how do we do this in GStreamer in general, right? I don't think we'll have an example in the Haskell bindings, so let's just look GStreamer. It could be that this is it would be interesting to think about it in terms of GES, but I think I want to do this just in terms of GStreamer. So GStreamer trigger event after some time. Seeking, navigation, and more. Event, pipeline manipulation, clocks, and synchronization. Sending EOS in GStreamer at a predefined time. Okay. Run, main loop run. New single shot ID in GST clock. New system clock, new single shot ID. Okay, let's check that out. I'm not what I wanted. Boom, boom, boom. There we go. EOS GST clock. After some time, okay. Single shot ID. GStreamer uses a global clock to synchronize the plugins in the pipeline. Different clocking implementations are possible by implementing this abstract base class more conveniently by subclassing GST system clock. GST clock returns a monotonically increasing time with the method GST clock get time. Its accuracy and base time depend on the specific clock implementation, but time is always expressed in nanoseconds. Okay, and right, GST clock new single shot ID. One needs to. Okay, a clock implementation can support periodic and single shot clock notifications, both synchronous and asynchronous. One first needs to create a GST clock ID for the periodic or single shot notification using GST clock new single shot ID or GST clock new periodic ID. To perform a blocking wait for the specific time of the GST clock ID, use the GST clock ID wait. To receive a callback when the specific time is reached in the clock, use GST clock ID wait async. So what is that person using? They do get clock, they get this self trigger. Send event. No, it's not self-explanatory because it's out of context. Where should this be put? Okay, there's probably some examples. In fact, there isn't. Maybe here. Okay, new single shot ID. Get the GST clock ID from clock to trigger a single shot notification at the requested time. Single shot ID should be unrefed after usage. Functions, ref and unref, and wait async. That's the one that take the GST clock ID and then a callback. And I think that GST on element pad added that also takes a callback. It doesn't. Oh well, hold on. It might. Yeah, no, it does. Element pad added callback. So some kind of subclass probably of the callback. Actually, there's a clock callback. That's a specific type. Okay. So yeah, so I think that's the better answer. Whatever the new EOS, no, send event, sending EOS in GStreamer using new single shot ID. Could it be that this self trigger code to send EOS? So it would be the EOS, but it's missing the callback. So that doesn't look complete to me. that creates a new EOS event. That's fine. That's not what we want. So now let's look, let's just follow what I suppose here the documentation is leading us to believe, that we need to get a clock ID. Hold on 1 second, let me look again. Here, for some reason, they get a clock and then a new single shot ID. But here it looked like we use, we create a GST clock ID with GST clock, or yeah, a new single shot ID. This gives us a clock. I know it takes a clock. Hold on, GST clock, new single shot ID. It does take a clock. GST clock ID from clock. Okay, so yeah, we do need to do that dance first. First create a clock and then assign the, use that clock to get a clock ID. So all of these things are different commands. Okay, that's all good. Let's look at what the equivalent of this is in the GIGST library. So get clock, element get clock entry clock timeout, structure get clock time, clock ID get clock. That sounds about right. And then clock new single shot ID. Yeah, so we should have all that we need around here. The new single shot ID. So where are we going to do that though? It seems like that would be just before running the loop, in fact. So set periodic clock. Yeah, we're going to do periodic actually. Yeah, it's better than single shot. Define in GIGST object clock. Yeah, so we need to import that. I suppose we can do it to the GST clock or GST clock bar, right? Right. We pass it a clock, the GST ID, to get a clock periodic notification ID clock. Yes, and so we thought it would be this clock ID get clock, but no, that's from a GST clock ID, so that's not it. Probably we need to create a clock first, and master, get the master clock, but it takes a clock, so no. Gets internal time, also takes a clock. Let's see, clock get time. Subclassing system clock. This looks like exactly the it looks like it's actually the API reference, but relinked to the GST library documentation. That's pretty cool. But how do we get the clock? Clock get time. That's supposed to take a clock. So that's just gives us the time. A clock implementation can support periodic blah. One first needs to create a GST clock ID for the periodic single shot, creating these things. Not enough. We want the equivalent of pipeline get clock. It's from a pipeline. That's what's happening. So let's go to get clock, element get clock, maybe element get clock. Is element a pipeline? Structure clock ID. I think a pipeline is an element. Get element set state. Yeah, it is. So let's do that. Clock ID, element get clock. So it would be clock that we would get from element get clock of gst.element get clock of pipeline. Yes, I think that would be it. And we'll get some clock ID. And we need something else here, a period, I believe. Word 64. Okay, let's look at the docs. Periodic ID. Start time. The requested start time. That should be something like now, right? So we probably need to get the start time and interval, but as a word 64. How do we do that? I don't know if the conversions, it's supposed to be in nanoseconds. How do we create these times? Window size threshold. So I suppose get time will get us the current time. So start will be gst.clock get time of clock, and then with start at start, and then interval yeah, we need to somehow pass a word 64. I don't know how these things are going to be cast. And it needs to be unrefed after usage as well, but I suppose that should be fine for now if we don't unref it explicitly. So let's just try what? So nanoseconds, so that's a millisecond, and that's a second. Sorry, no. It's nano to, yeah, to micro. So that's a microsecond, and that's a millisecond. And so that's a second. Holy moly. So let's try that. And then, so we get that periodic clock ID, and then we use this with a ID await async. It is a callback, that's right. So why is the cannot deduce clock get time? Maybe clock to IO word 64. Ah, this is a maybe clock. Okay. Right, let's make this partial. Import from a data maybe. And then, is that a maybe as well? No, it's not. But, right, okay. Yeah. So I suppose we should put the from just right here instead. What's the deal? Right, we need to fmap it. Yeah. Okay. Awesome. And now we clock ID wait sync. with the clock ID. So that would be, maybe we call it every second instead, right? With a clock callback. And we need to create such a thing. And that's going to be what? That's going to be something like switch file source or switch location. And I suppose we can just let switch location, make it of type clock callback. Clock call back. No, not that. And then go check out what the clock callback is supposed to be. Clock callback is clock with the time, some pointer, and true false. The function prototype of the callback. PTR ID, that it just doesn't sound right. So let's take a look here at what element pad added callback is like. I think that would be a similar thing. Element pad added callback gets a pad and returns an IO. A new pad that has been added to the element, so we get the pad that's been added. Okay, right. So no, it makes sense now. The clock, we get the clock that triggered the callback, the time at which it was triggered. Okay, so yeah, so we can just ignore those things. I think we ignore the time, the clock, we ignore the time, we ignore the GST clock ID, and we could return true or false, but that doesn't matter. Okay, so we just do something like setting the I'll add a another parameter here, b, such that case b of true, then we shall yeah, that's actually not exactly going to work if I do this like this. Yeah, okay, maybe I'll do a single shot. I suppose if I wanted to do I wanted to do a kind of a flip-flop thing here, but it's not going to work because it doesn't call itself recursively, right? It just calls itself with this. So we'd need to sort of wrap this into some state. No, that wouldn't even work, in fact. Would need to somehow yeah, I think we'd need to update. We need to do single shot that calls itself, and then free the previous single shot ID, and then reinstall a callback for the next call. That would so yeah, that's not elegant at all. That's the kind of imperative API that we have to deal with at this point, but it's not so surprising. let's see. So what do I want to do then? Shall we just try the single shot? I suppose that would already get us a sense that we've done what we wanted to do. We're not, in fact, we're not necessarily exploring the time related API. We're supposed to just want to try and change a property, but it's still obviously super interesting. But let's not go to too much down the rabbit hole. Let's just say that instead of a new periodic ID, we'll get we can re-init. We can re-init, but yeah, that's still not exactly what we want. So let's just do a new single shot ID, and it does take I just take the requested time. So instead of start now, we're kind of saying start plus, right? That should mean a second after. So after a second. And then we just switch location, and we don't really care of a Boolean. We just say just what? Well, we take an element which is going to be the source element, and we want to modify a property of it. So actually, it's something like that set syntax that we saw in other places, but I don't remember here. So set element, path set element private. I think it would be set property. I think it's set object property. Okay, maybe this will give us info. Set object and the blah. So I think if we say set object and location, and then we give it this location, then what? Then maybe we don't. Right. No, we do want to return true or false, and it doesn't matter which. So are you saying you want something like that, or set text and O, this kind of attribute and attribute set. So maybe we need to do this old thing. A non-attribute location for object element. Yeah, that's all good. But so maybe we just set object property string. I suppose we do have the example right here. But maybe it's worth trying to see whether we can find another way to do that. Set object property. How come this isn't in the... Oh, because it's probably the underlying GILib, not the GStLib. So let's, how do we check that out? Here, GILib, glib, and index, and all. And no, it is not in the glib bindings. Oh, data.gi base properties. Interesting. Where is this? not here. Base already, right? Conjugate base. Yes, yes. Properties. There we go. Set object property string. Yeah, so that seems to not be using any of the sort of the niceties in the API. So how come we can't do set source then? What's preventing us? It just doesn't find a location object, a location for the object element. So source, is it because it's a dynamic? It's not a dynamic element per se. I suppose the fact that the examples used this seem to mean that we actually also need to use this, don't we? Let's take a look at the GTK bindings, and let's see. Let's look at Oscar Wickstrom's example and see whether we can draw any parallels between a window and title here. Yeah, I suppose that the fact that every element is completely dynamic means that you can't have a language level label like this. You need to stringly type it. Unless you start basically wrapping the standard library of plugins with these properties, which in fact could be possible to do with code generation, if I think of it, right? No real reason why we couldn't introspect, we couldn't get not just the GStreamer base, but the GStreamer plugins, and then start generating code from them. Now that's a whole other area of potential work here. I'm just going to take a note of it, I suppose. Generate binding for GS. I might not put this in to-dos. I might put this in something like stretch goals. Generate bindings for GST plugins to be able to use set source location equals blah. Notation. Okay, but right now I think I understand where we don't have it, and therefore we just set the object property string instead, and we do so with this string. And I am lost with my keyboard shortcuts. Okay, I think we need to, well, we have overloaded string, so we shouldn't need to pack it. And this is also indeed not needed. So let's try and run it. Okay, from just got an error. So we didn't get a clock from the pipeline. Why not? Get the list of tracers. It says that it's now playing, but then it actually gets nothing. Get clock, element get clock. An element to get the clock from. Gets the correct currently configured clock of the element. The clock as was last set with the element set clock. Elements in a pipeline will only have their clock set when the pipeline is in the playing state. So we have to wait until it's actually finished to be in the playing state somehow. So do we need to register? How is it done in the example? Maybe this is synchronous. I suppose the fact that it waits for a bunch of stuff, including that the element pad is added, yeah, it means that we probably do want to wait. Let's look at what the on handlers are. On element something. No more pad, so that's the ones on bus message. Do we want to do this with the bus? Playing, state playing. State change. Element state change return get name. What is that? Gets a string representing the given state change result. Okay, where are we here? We're just in element. Call async. A state change has to be performed from a streaming thread directly via element set state. Okay. How do we know whether, I mean, I don't expect that all of this will be happening in the streaming thread. But yeah, that's tough. Element change state. Okay, let's look at pipeline again, see if we see something in there. I get pipeline clock. Yeah, that's much better. Alright, it returns a clock. We don't need the from just then. Oh yeah, that's much better. Okay. And it didn't switch. So, but it could very well be. Let's clean up a bit all this mess, right? And let's also let's add a print switch, and let's the warning. Print message types. That's what's getting the log a little bit overwhelmed. And then I suppose it must be a like our Word 64 conversion. That's, we create dynamic paths, we run the thing, but it doesn't switch because probably this isn't right. So let's lower it from one whole order of magnitude. It's not an order of magnitude, actually, it's more. Okay, still not. And we also don't see, oh, it does say switch here. So it, and then changing the location property on the file source when the file is open is not supported. Okay, well, that makes sense. So what do we do? I suppose we need to maybe open a new, you don't need to unlink and add a new source, just go straight to ready. No need to go to pause and then to ready. Okay, ready to playing. Okay, sounds good. Let's give that a shot. So how do we set the playing state? See, that's exactly the type of stuff that I wanted to learn. Like not a lot of necessarily super complicated stuff. I mean, we almost went there with trying to set up like a dynamically stateful kind of clock event or whatnot here. But there's obviously much better declarative API to do that, and hopefully we'll move to them like with Dunai and Ryan and so on for managing clocks. But here, for instance, that's definitely useful to know about programming GStreamer, this kind of stuff. So, and setting the state for pipelines, obviously something that's probably going to be very useful to do. So state element set state when the pipeline performs the pause to state. Let's see, is there anything you can see here? Oh, what's auto clock? Select the clock automatically, default behavior. Okay, use clock. So it's not clear how we change the state. Set delay for element to perform pause to playing state change. I see. Set latency. Okay. So flush, pipeline delay, and latency. Right. So given that these properties are static, then we can use this syntax, right? But given that elements are super polymorphic, we can't do that. Okay. So element set state then, I suppose. Let's try it. Element set state of pipeline and a state. And what are the states? State change playing to ready, playing to paused. That's a state change, so maybe that's not what we want. Paused, state paused, or a state ready, right? And then, right, we have a GST state playing here, and then we go back. Ah, yeah, so we know that that's the correct syntax. Very good, very good. Except for the GST right here. Okay, let's give that a shot. All right, it changed right away. So we just need to add, I suppose, some zeros. We don't know yet how many, but we shall find out. Yes, so this looks like this was 1 second, right? Let's try the one more zero and see whether it looks like 10 seconds. It does. 8, 9, 10. Switch. Yes. Excellent. All right. That's good. That's very good, right? So we can tick that box and we can move on. Dynamically change an element. So now, one possibility is to get to the declarative API and see what we can do to do that. The other is to try and go play with GES. I think I probably want to do just a tiny bit of understanding how we're going to do declarative API. And we actually did some sort of study work here. So let's catch up with that. Rendering would become a pure function from state to declarative widget. Yeah, I'm going to open the blog post, but not only, I'm also going to open the declarative. I'm going to open the library code. So let's clean up a bit. This is going unruly as it always does. And GXTK and GXTK declarative. And let's see, something such, I think widget is one of the most common ones. But I think, yeah, we left things at the point where he was about to show the difference between imperative style and then the actual declarative style. And we want to do that for our pipeline. But let's read through what we wrote last time we studied this. So rendering becomes a pure function from state to declarative widget. So that's something we see here. View prime is a rendering function. It goes from state to the widget. And it does some diffing in order to do that. And in this case, well, the state is either not clicked or clicked, and then it just swap for a widget or the other. And I suppose that this widget event here, this is the declarative widget, which I suppose then has, yeah, it is the declarative widget, has its own diffing function, which is the patchable type class right there. So then it knows that when it moves from what is in effect really kind of a stateful or a data version of the widget. It first creates that data representation of the widget, one or the other, and it knows how to translate the diffing of two data, two output data represented widget into a imperative command. So for instance, if it goes from this to this, then it knows to patch the label and it knows to leave the event handler, I suppose. No, then it will remove the handler. So it will replace that list by this new list. And sensitive false means grayed out, I suppose. Yes, excellent, excellent. And so the workhorse then is dispatchable, which is a kind of a differentiable programming or incremental programming construct, I suppose. So it knows how to create something, and then given two different state representation of a widget, it knows what to modify and or what to replace. Meaning if t1 equals t2, meaning the widgets have the same type, then it knows to drill down inside the widget state somehow. Yeah, I think it must be recursing through, because I think we have a tree of widgets. So I think it this patching here, yeah, widget is itself patchable by delegating to the underlying widget instances. Ah, right. So then I suppose some like button is going to then have a its own patchable instance, right? Maybe single widget. A single widget has a patchable, and yeah, and I think a button is a single widget, and so then it will do, what will it do? Create is this and patch is this. So yeah, we'll take the state tree and then one single widget and then the other single widget, and it will ignore the old attribute, and then it will do whatever it needs to do. I notice it's also it's returning patchable or patch yeah, returns into a patch data type, which has sort of modifications. And so this must be then interpreted into some, I suppose, like something like a free monad when actually doing the patching. And so that must be, where would this be done? Let's search for replace, for instance, and see. Ah, there we go. Menu item, for instance, knows how to. So each individual widget will know how to handle each different outcome from the patching, I suppose. So this is in the right hand side position. So how come menu items seem to have a left hand side here? It's in the left hand side, but it's really the transformation. So let's take another look at the search here. See if there's other left hand side. Container patching. Yeah, that seems like maybe more like it. Yeah, that's right. There's a Go, and it's a patching container. Patch all children in a container. Interesting. Noted difference with React here. So Go is fault mapped over the children. Not sure when patching container is called. Sorry. And this is whether there's whether it's a new widget or one that we remove, right? Or there's no widgets, so nothing to adjust. So it seems like, yeah, this is the old child state, this is the old widget, I think, and then this is a new widget. If there's no old widget and that we're just creating some new widget from an old child state, it's replaced. Yeah, we need to know when patching container is called, and I think, yeah, this is all about this state tree of widgets that's maintained. I wonder whether, yeah, I suppose that we might need to do that except we manage a graph for the pipeline. Okay, I'll look at this in more detail in a bit, but I'll take a little break for now. All right, I'm back and doing some declarative GST if we can. So yeah, so what I was saying is probably if we want to do any of this patching thing, then we'll need a state graph representation of our pipeline. So that would be one of the workhorses. And then we need to think about what patching means. And yeah, I think, yeah, that graph patching. And then can we make this a, and maybe we need to make this sort of thinking about the correspondence between something that feels like the adjacency matrix representation of a graph and structure of that. And whether that corresponds at all to some of our earlier design thinking around, which I have actually do I have any of this working right now? It doesn't look like it. Let me see if I can turn it on. No. Oh, maybe here. What's that? No, I think that's yeah, that's my headset. The VR headset. Right, yeah. After a while, my OBS actually complains that I'm trying to open more than 16 video devices, which, yeah, is a problem. But I don't know how to fix this. So let's leave it at that and go back to my main screen. And maybe I'll just put this in front of me. Take a look at it. Right. Yeah, I don't know whether some of the routing UX paradigm I've been talking about in some of the past streams somehow reduce to a sort of a adjacency matrix plus sub adjacency matrix style representation. In fact, it could be that that's the case. I don't exactly know how to check that, and I'm trying to think about what's the best way to progress here. It could be that it is related to defining a state graph pipeline data type. And trying out maybe different representations for that. Let's see where this type is declared in the GTA declarative library. State tree node. Not obvious, but probably here, right? State tree. It is a state tree and then state tree node. And a state tree container. Oh, that's is that a data kind? And it's a GAVT. Interesting. So it's a state tree is parameterized by its state type which is one of these three things. And then depending on whether it's one of these three things, then it has one of these three shapes, I think. Let's go and take a look at what we were looking at just earlier. The patching container that returns a state tree container, and the type of that is state tree with container state as a type level parameter. So indeed, it is that state tree type, and there must be some state tree polymorphic things, but I suppose in this case it's instantiated to container state, and then it's in this case taking a container state as input and then returning a container state as output. Will we have something like that in our case? I don't know. It's possible but I'm a bit surprised that this wouldn't sort of interleave in some sense. There's also a concept of state tree node. That's common structure for all state tree nodes. State tree node here, state tree node here, and state tree node here. But I'm still surprised that these wouldn't somewhat interleave, that you wouldn't have, a container inside a bin, inside a widget, or something like that. Because I'm thinking that's probably going to be the case for us, that we'll have bins that might contain subgraphs, and we want to patch those, which starts to make me think about what is it, decorated cospans, like the category theory sort of aspect of what you need to do to connect graph structures, or to compose graph structures together and within each other. I've thought quite a bit about this issue. I suppose it is a really good concrete example to try and play with some of these ideas. But we probably also want to start fairly simple. And we want to think a bit also about whether pads are in some sense pads are objects in a kind of category, in kind of our graph category, and then elements are arrows. That might be the proper abstraction. But I don't know how directly we can encode that in Haskell. If we start erring towards how categories are described rather than how graphs are described, then we'll have less tooling. But at the same time, like a typical graph, I don't think that will be very useful for us. Like I did mention the alga representation, but typically I think unless we have labeled edges, so that's the alga data type. So the empty graph, a vertex. So here we see we're not categorical. We can have a vertex. We can have single vertices, or and that doesn't mean anything. In fact, really, in a pipeline context. So we see that we have a kind of an invalid state represented in some sense here, if we go that route. And then at this point we start potentially connecting to vertices, and then I suppose a vertex is a kind of a pad. But here also, now I'm wondering about like the fact that we instantiate multiple paths, for instance, and how is that even represented? Also because we need a sort of polymorphic E and A here, which makes this even more complex. And we did start playing with something in model, right? And using this, trying with the variants, right? And so this didn't start at all from a graph perspective. It started more from a matrix perspective. But I suppose there is a question here, like if we have this kind of extensible language, although this was mostly to, yeah, this defined more sources and sinks, and then possibly in this matrix, like this routing function, maybe there could be some of the smartness we need to describe elements, but I'm not even really sure of that. Because here most of the data is in the sinks and sources, which is probably fine, but at this point at least there's no clear way to, I mean, this could be an edge instead of routing, for instance, and then you could say that it encodes some additional data at the edge, maybe by making this giving it some edge metadata right there. That's a possible way to go. Hold on, let me blow my nose. Okay. So the attraction of this, of course, is the graph constructs. But will we have any real graph constructs somehow in this pipeline world? It's unclear. Let's look at Haskell graphs in adjacency matrix. Labeled edges, if we can, that'd be nice. Function implementation of graphs, labeled graphs, adjacency matrices, edge label for algebraic graphs. How is this? Traveling salesman. Tying technique for circular structures. You can represent your graph in an adjacency matrix. We're not going to need cycles. Let's just look at adjacency matrix data representations. I think maybe in FGL there's going to be some. The graphs package, simple monolithic graph package, from Ed. And what about FGL? Basic inductive graph. This wasn't very easy, if I remember correctly. Yeah, the types were a bit obscure. Graph of characters. A is, yeah, I think that's something like an adjacency list of sorts. That's the underlying representation for the graph. So how did it work? I think incoming and outgoing, I think it was something like that. What about at library? Not very Haskell API for calculating traversal graph that may be too large to fit the memory. Create an adjacency list where the vertices are labeled with integers. Need a data structure that instantiates monoid to combine the results of our visitor functions. Enter V, enter E, gray, exit V, black. Is that for, that sounds like an algorithm, I don't know. NTFS function first argument is of type graph search. NTFS function is not listed here. It's supposed to be orderings. So graph search is this. It's of type adjacency list orderings. Orderings being this thing, which is a visitor containing the functions to be run at various times during the search. So when we enter AV, is that right? When we enter an E, and the gray and black, I don't know what that is. And when we exit a V, run adjacency list, unwraps the function in the adjacency list new time and runs it on a graph. I suppose unwraps this function. And our graph was this array. What is this? arrays. What's the kind of array? It's the index. The type of it says it's type to type to type. I thought it was type to type, so I was confused. So a pair of bounds lowest and highest indices in this array. Yeah, okay. So that's the indices, and then the content is the list. In this case of, so 0 is outputs to 1 and 2, 1 outputs to 3, 2 outputs to 3, and 3 outputs to none. So that's the encoding. Good, that's what I was looking for, right? That's, well, no, that's not exactly an adjacency. That's what you call an adjacency list. Oh, okay. So can we do something like that, but where, suppose we attach some pad property to the index, and then, well, then a pair won't work because we need some, that's not labeled edges. Those are simple edges, so we need something else. Maybe a pair of some edge data and edge incidents. So it would be source, edge data, and destination. But I suppose edge data and destination would be. So let's try that. Let's see. So algap, I don't think we can go back to it, but for some reason I get the feeling maybe it won't work. Here we're saying something like import data array, which I don't even know we have. We don't, but it's here by hidden. Okay. And let's restart LSP. And so we would say something like pipeline. Our pipeline, I suppose, would be of type of array of, like, well, I suppose we need to say int. It's going to be very weird. And then some elements with some ints. I think maybe we can right, we need IXI. So we could just create a IX instance for pads. So we need an instance of IX pad. Pads. What does that look like? IXPad, right? And superclass of word. I mean, I suppose we should start with some example. It's not clear how we're going to maintain that. No, that's not true. I have some vague intuition on how to maintain that. Implementation is entitled to assume the following laws: minimum complete definition, range, index or unsafe index, and in range. Okay. So what is a path going to be? For now, let's assume it's like audio and an int, and video or video and an int, something like that. And so range would be of type A to A, or pad to pad, to a list of paths. All right, so yeah, so we suppose that this int, which is more of an at, would sort of be auto-incrementing. And so we need to do some bookkeeping to ensure that these are unique, but this should be fairly easy. So what's the implementation? Well, range of, there's only a few types. There's only a few occurrences. That's it. We don't, so that's weird though, right? That we can't, yeah, it is weird. We can't do that. We don't want to segregate audio and video. We need to have them as a kind of a pair. We need to have the same, everything needs to be indexed with the same. So we probably need to put this in a record, in fact. Or do we? Because I want a sum type here. So I suppose, yeah, I suppose I need to just define a sum type here. I suppose I can make this a type. And then path type is audio or video. And so here our pad is in fact either is an I with something we can in fact probably ignore, can't we? That's going to be tough, because if we ignore it, then how do we generate them? Maybe we have a, yeah, we need a default thing, like a pointed thing, sort of like unknown or unassigned or untyped or any, maybe. And so then if we given a range, yeah, if we given a range that's specifically asking for audio and video, if we're asking specifically for audio, then we should return range ij f mapped to a section like so, if this can be done. Is that a proper section? Maybe that is. Such that then it would be the same thing for video. So in that case, No, I think we need to distinguish them, because if they're, I was going to say, well, then we can, you know, call this T and then map T, but we care about whether, well, yeah, I suppose we could do this with guards then. Okay, so maybe we say something like if, well, T and U. So if T equals U, then we do this. Otherwise, we do any. I think that's the correct thing. And then we need index, which is of type pad to pad, and a pad gives us back an int. The position of a subscript in the subrange. Okay, so I think we don't care about the type here. We have a K here. Oh, like that. And then we probably just do index ijk. That's it. And then in range is what is a so it's pad and bool. And again, it's going to just be in range and in range. And then we'll need a type element. Let's say that it's data type element. And we'll say for now that it's either like whatever, convert or source or sync, for instance, right? Those are some of the main things. And then we'll define a specific thing, and I think we need to use the array function for that. And we'll say, well, let's just define a graph that's like just to, I suppose, like the trivial one with just well, we'll say from 0 any to 2 any, and it will start from 0 any and then it will have a list that it outputs to, but before that it will have the element, and so this will be, for instance, the source, and right, so I think we have a kind of a bounded range of some sorts. Do we? Because I'm thinking when we say source, probably we should pick like some kind of 0, some kind of bottom element. Should we though? I think, yeah, I think we need to, in fact, So we shouldn't pick int. We should pick another thing. It's kind of an initial object in the category. I mean, we could say that it's just 0 any, or we could say that it's 0 null or something, but I'm not super confident about this product type right there. It feels already a little bit sketchy. So maybe we say initial hold on, is it this about paths here? Yeah, I suppose it is, huh? There's the initial, there would be the initial pad, there'll be the pad, and there'll be the, do we need a terminal pad? I suppose, again, yeah, it's the thing that syncs are just terminated with. I think it makes sense, but now, indeed, we need to cover more cases. Oh, you do need to use double sections for that. Okay. Can't we fix it? Yes, we can. Nice. Except now, indeed. Oh, instance 6. Yeah, please allow instance 6. Thank you. And yeah, now we need. Yeah, now this is going to be for pads. And that's still valid for pads, but now we have another case. A few other cases. In fact, yeah, quite a lot of cases. Okay, let's call them init and term. So we have the case where we yeah, I think we want range first, and if we go from init to pad, then range ij. This needs to be pad. Yeah, and in this it shouldn't be that. So what will it go from? It will go from 0. So we can need a bounded int. That would be really the best. It's too bad we don't have something for that. There's no reason really, is there? Haskell bounded int. It's bounded int. Has a min bound and a max bound. Huh, so maybe we just use that as the init int and the term int, and then we don't have to change anything. That would be better. What? Hold on, isn't this exactly what we had before? We had actually a type synonym, but then we can't define an instance for a type synonym. Is that what's happening? Oh, but in fact, in theory, we can. In theory, but flexible instances as well, and overlapping instances. Whoa, how come we need all of these instances? IXPad, matching instance. Because we have a pair instance already. Oh, wow. So, so we don't need the instances? Well, I suppose that's better. But then we want to rename init as minbound for and as type int, and term as max bound. Hold on, that doesn't make sense, does it? No, it doesn't make sense. I think we need like a bounded, even bounded nat is not going to make sense. So we just need like a bounded fin, I think. So maybe an int 8 is actually not a bad idea. But no, because as soon as we try to do something with term, then it's going to not work. Unless I suppose we do have manual instances. Well, it doesn't tell us that we have overlapping instances because we have a type constructor. All good, I suppose. But now we need to do the trick, right? I mean, the trick is, I think, in the case where we're trying to terminate something, but if we have a range, we don't want to iterate until the end of the world. We want to basically just iterate to like the next available largest integer of sorts, up to max bound. So how's that going to work? So the example would be, we go, well, yeah, ideally we want to say that we go from init to term, but we can't really say that. So I think in that case, we're back to having these different types of paths. Having an init one and a term one here. And needing to make this a data type, and therefore having to specify what's up for the other cases here. And what are the other cases? Well, so init should actually return the empty list. In fact, same for term. And so the interesting cases are, I think, init to pad IU, and I think, what is that? I think it's just init const with pad of u, or we can call it t, applied to the range of 0 to I think. Maybe we could, no, not. And then I think that's sensible. It means 0 has a specific, I mean, again, we can do the accounting outside so that this mess is not visible. And so then what happens if we say this? Then I think it's just yeah, that's tricky. That's tricky. Because it's kind of stateful. Meaning it depends whether I is the last. We need to go from I to the last of the path that have been allocated and then terminate with term. But I don't think that's doable. Except if the paths carry their current count. Which is well, hold on. Is that how they would carry it? A bit tempted to do something like this. Yeah, now I'm starting to wonder about. I'm going too deep into the data structure in my head. I'm now trying to think about how we'll want maybe maybe index monads, maybe like just to define what connectivity is possible between elements. But yeah, that's going too far, and I suppose that if a pad is this, it seems like the accounting for the number of pads, there must be a smarter way to do this so that we don't have it in each of the leaves, but that somehow we manage to carry it somewhere at the head, if we can, of a recursive. So yeah, that will go against this, I think. This list of pad. No, maybe I'm just willing for now to just spare the extra memory. And then is it the case that init and term like just don't carry that? I think they need to carry it. Maybe not, maybe not. Let's try without it. So in this range, we ignore it. We could do a double check, but we don't need to have it. In this one, we also can ignore it, but in here, we don't. And this becomes a J. And we go from I to J. And we put a term at the end. And we need to put a value in here, and so here where we can call it C as count, and we can put it back here, and let's call it C here. And then I suppose, yeah, just this C is just I to C. Isn't that right? Actual type blah. Right, yeah, you can't add a thing at the end in such a way. So if we don't want to, we have to waste, we have to relink the whole linked list. Here it's expected that, is it expected that they're the same length? Or does it not matter? Give me all the paths between these two paths. I suppose it would, if we had an older version of a pad. So you know what, let's, if C is different from D, then that's just error. I'm not even sure this is going to work. I think it's not going to work. Yeah, I think we can just concatenate, use this concatenation here. And yeah, no, that's fine. Right, so in truth, right, if we go from init to term, I suppose that that's something we don't have in our, if we go from init to term, we're a bit stuck. We don't know what to do. Huh. What? And so we can't really go from init to term here. We have to go to a certain number, and so we'll say just 3 or 2. So that should give us 0, 1, 2, but we start with init. Yeah, I think this means this representation is not going to work out for us, but I could be wrong. I might be trying to be too smart. So source is just going to go to pad. And what's the, yeah, right? This is pad. I think you would say pad 2, blah. And then here, pad 2, 0, any. And you're saying I could remove this, and I agree. And what's up here? Ah, we need ortpad. That's very true. And so we need to be able to compare. Well, we can compare init to term. That's what is it? greater. Yeah. And we were going to need EQ pad, but that we can probably derive, can't we? Deriving EQ. As long as we also derive EQ here. And then, well, actually, init to anything is greater, and anything to term is smaller. That's part of the dealio, I think. And then any pad, anything with a pad j anything, it will be compare ij. I think. Yeah. So in theory, that's how we would then write our pipelines. And then here we'd go from pad to 0 any to right, like some to some pair, one with the type of the element, probably will have some payload, and then where it goes, and we'll go to something like pad 1 any truth. We'll probably want to have names here, like text or something. So we would import that text, and we'll overload the strings. And then we'd ignore this pretty much everywhere. Oh, except how do we create a range when that's supposed to have names? Interesting. Yeah, so I think this stuff doesn't quite work if we do it like this. I think probably we just want to hold on to identifiers and then have some other table where we map or something, or another simple array actually, where we hold on to those indices and their actual content. And I think that solves a lot of the trouble that we were trying to solve with, well, I don't know if this solved the init term problem. Maybe it does not. But I think it's solved. Does it solve the count problem? I don't know. Huh. So if these were all indices of paths, then we'd still need to have an index for elements to have like labeled edges, and there could be a mapping from those. But then of course then there's the question of the fact that paths really are related to elements. So still some lot of room to think about how to actually represent this. But I think this is all, I mean, maybe the init term thing we can keep. The okay, right, the count thing, no, we need, we'd also, if we have an init and term object, then we need to, and we can't work with ints without keeping track of them because of the term thing. Okay, so let's just remove this, and we say this is the int that actually index the pad. And so in which case we don't need the pad. Do we need the pad type? Yeah, it depends whether we want to check for validity of the pipeline construction methods based on type, on this pad type. So no, we probably need to keep that as well. At least to avoid some having to look up inside the pad, having to do a lookup. This feels clumsy. And I'm still nowhere near to see whether my AJCC graph intuition somehow works out. I suppose let's call this maybe pad node. And then the pad, there will be a way to get from, whoops, a pad node to a pad. I suppose we have to do pad nodes here as well, right? Okay, let's replace pad with pad node. And so we'd have something like a pad will be pad and some text for now, and then so you want a new type, is that what's going to advise me? And then oh right, but an int. . not. Maybe a pad is just this. And it's just that we have a pad container, like a pads, which is not a map, but maybe just an array of pads. Yeah, I suppose so. All this feels a little bit self-referential, but this int, despite the fact that we have an array of pad nodes, we have this sort of adjacency matrix here. So we have sort of the structural element, and then we use this data structure to fetch the corresponding pad. Like a pad registry of sorts. Yeah, I suppose that's fine. Ish. And then don't we want to do the same thing for the elements? It seems like for now, if we call this process, then each element, like an actual element, there will be an element edge, and then an actual element will be something like element of text and probably many other things later. And then we can also have some data structure that hold on to elements by the int. A multiple declaration of array, of course, because this is a type synonym. This is not a new data structure. Okay. Oof. Don't particularly like all this, but this is the natural continuation, I think, here. And here, this would be process 0. And we need to do all of this accounting of things, which sounds terrible. And then this would be process 1. And then this would be, well, I suppose maybe we make this 1, and then that's it. Or maybe we don't need a term. Maybe that's term. And then we solve our term and count problem. This feels just a tiny bit arbitrary, but I feel like probably we want that, especially if it allows us to remove that big word. So let's remove that big word. Okay, I think that means we need to basically do this. And then remove that int. And then we don't have term neither here nor there. And then it cannot make sense to have that in it right here instead. Some cosmetics. And then indeed term doesn't exist anymore, and so we don't have to do any of these ugly things. And I see. Yeah, we can probably hide index from here. And then we don't need that C or D anymore, or that text, or that C, or that one, or that one. And then what's that? Element H. Yeah, that's right. It's element H. And pad node. Okay, and then there's no CD. So in theory that compiles. So that's just a very simple pipeline. It's straight, and we can't really see that at all. Adjacency matrix. Edge. Ah, right. It's so that's kind of the routing function, actually, right? That's my routing, taking inputs and outputs and determining whether there's having the possibility to have something or not. So in my case, route takes input to inputs. So there's a bit more to it that I'm trying to encode here. But that was my thinking, that this was like an adjacency matrix. And okay, what's missing? It's the fact that I think index, it's an adjacency matrix where the edges are labeled by functions. I mean, here also I was trying to capture maybe like a hypergraph with multiple inputs and multiple outputs. And we don't need to do that. Also here, right, this is a list. Yeah, that's because here I have a list of possible outputs. So arguably something like the IX of outputs. Although here we don't have that concept at all. Is it because it's the class? Array I blah. Ah, maybe it is because it's the class. So it's a classified version of things. Here it's only RIA. Hold on, what is that? New type blah. Yeah, so it's a bunch of functions. RIA-able to A. And it's used here with A being RIA-able. an ID. There is some smarts there in how this is constructed. That's escaping me. I need to see it used. Is there going to be an example or some tests? No, of course not. Of course not. So the question is this just a helper type where what we really want is in fact this type? Maybe, maybe not. I think so. This type makes it so that if you pass it an RII bool, you say this edge, and then it returns an RII bool. Which will confirm, I suppose. I suppose it will ignore the bool, though. I don't understand this. It's almost like I understand the, I think I understand the class version better. Given two vertices, there might be an edge. Yeah, so simple. But there is an instance of it here, right? Adjacency matrix graph, is that the, yeah, that's the one. So maybe we can recover our understandings for that. Because this is adjacency matrix. So maybe, so it's an adjacency matrix containing it, containing vertices of type A. Is that the case? Such that given two i's, which index those a's, no, that doesn't make sense. Why would you return an a? Unless a was the label of the edge, but II is an edge. Okay, let's look at this. So edge ij, where I is a vertex, j is a vertex. Yeah, so there is a continuation kind of thingy there. That a is not meant to be an actual final type. It's meant to be some kind of function. I think that's something like what a final encoding, or maybe initial encoding, where it looks like a functor with a carrier type A, where you recurse, you put, like here, you put your adjacency matrix inside your adjacency matrix. Right, check this out. Vertex adjacency matrix Ri is I and edge is II. That's the graph instance. I think it could be also something, because I've been for a while misunderstanding this notation too. This constructor notation has been baffling me forever, and I don't think I'm getting better at reading it. So let's write it down and then think about what it would be without this, without the run adjacency matrix. Haskell data types constructors record notation. Record constructors. So name string means that if you run adjacency matrix, okay, I think I need to do the simpler case just for learning. Like A equals A, run A to B or something. And let's say it's AB. Then if I have some A in bool, well, if I have an A, then I can run A on it, and it will give me A to B. So if I had run into bool, and if I run, if run is run A of A, then that should type check, as long as I'm able to build some A here, which I don't know how to do. But let's say it's like how I read it, that it's actually yeah, so that type checks. So adjacency matrix is something that takes an R oh, I think I was reading this R incorrectly. It's a type parameter. It's not array. I think it's, is it the adjacency matrix? No, I think it's supposed to be array. It's unclear. In-range bounds a ix. So yeah, a seems to be r in that. That example. It's an I array of R bool. That's not in no, those constraints aren't in the class definition. Okay, let's just try to import this and play with it. So in theory, I could say that G is an adjacency. Well, I need to import data graph adjacency matrix. Then I could say this is an adjacency matrix of what type? Array, I suppose, and then int, and then some text, maybe even a pad. How about that? And then I'd say, well, G equals adjacency matrix of indeed something like that. But so it will be a function from an array. So I'd get an array here. And then I return some pad. So I suppose I could make this sort of const the empty pad for now, or the init pad. What pad is, well, let's make it pad node, huh? And then let's say init. So you're happy with that? Types checks. Okay, so you're really saying you're getting the whole adjacency matrix here. So what can we do with arrays? if I have an array, I guess I can construct it with R, but here, well, I want to deconstruct it actually, right? So I could get its elements. It's confusing me quite a lot because I would expect to pass this vertex pair and then get a bool. But I suppose that's the full array of all the vertex pairs and bools. So it's to say that there's somewhere but I would want this to say that there is such a adjacency matrix inside the data type, but here I read this as we get it passed to us. If we get it passed to us, then how is this defining what the adjacency matrix is? That I do not understand. I think I understand the adjacency list. Let's look back at this. I suppose if I saw this, then I'd be confused as well. I think that I'm being passed an array, but in fact, that's really not what this is doing. So that's the data. And I suppose the data is not the same. It's kind of saying that the go at the adjacency list. That's the data of the graph, and I think ask is a constructor for that. I think, is it? Let's try this out. I want to learn about this particular way to encode things. So if we say G1 is array of int and pad node, and then we say G1 equals array, and that we build this array from like 0 to 2, and that in there we build this thing from 0 to 1, and from 1 to 2, and from 2 to nothing, for instance. Right. Then indeed, those will be the indices, but here we need pad nodes. So here we'd say something like init and pad. What can we put in there? Pad node and an int, and some type, and then say pad node, and then same int and some type, and then we'd say, let's say we finish now and maybe do 0 to 1. What's the deal? There's no term anymore, so we just close it, and then array in pad node, array pad node. Yeah. What was I doing? Array pad node and blah. Yeah, I suppose I am doing array pad node. Hold on. Maybe I should do array in pad node, because maybe I'm missing something here. Into list event. Yeah, no, I think it does need to be pad node to pad node, and here be init to pad node 0 any. Yeah, and I think we can just get rid of the parentheses, right? Don't know where I have that. Yeah, except this. How are we gonna do this? Little trick. If we don't have section tuples, well, we do this, I think, right? Yeah, I think so. And you have to get indentation, right? And any here, if we don't know. Okay, let's proceed. And okay, and then it's not exactly that. Pad node int and pad type. Pad type. Right. Right. Yes. Oh yeah, I'm afraid I'm going to have to do maybe I can do flip pad node t blah. That'll work. Maybe it's flip pad node. Yeah. Haha. And flip pad node t. And okay, we need the parentheses here. Good. And then we need to switch this example. Yeah, for some reason I haven't yet internalized the whole, you don't need pair. Yeah, I think I removed the wrong thing here. Yeah, and if you don't need pairs, then probably you also don't need a pair here, or do you need a pair here? I might here. Okay, and then here we also do our thing, and then it's like this, and it's a little bit less painful to write. And I suppose no, we do need that thing. Okay, so now let's do some stuff on this, because that's something we haven't done so far. So we can run adjacency list to unwrap the function in the adjacency list new type and run it on a graph. So let's try that, whatever that does. So we don't have orderings, but don't we have that from you're not providing that? That sounds a bit strange, but let's try this. So now we have orderings, and then we need these orderings, and then we need graph search. Where is maybe depth first search? It's a graph search, and graph search is in data graph algorithm. Okay. And then GFS is going to be in here. Okay, and so we're supposed to be able to GHCI into this. So maybe cabal REPL. If we next develop, Haskell.next is parsing our new cabal file with the new graphs library and making sure that we have all the dependencies, system dependencies for it. Is also running If we wanted to have a local Google, then we could. Do I have this defined in my flake that I want the Google stuff? I don't think I do. I suppose it might be possible to deactivate it. Maybe that would make Nix develop faster. But here we go. So what is it? Plus M and model? No. Yeah. No. I put this in declarative. But this doesn't compile anymore. Why not? Can match path node with int. Aha, yeah, because this is for ordering that is for an int. Fine, we'll try with this. Try with ints. Try to understand how things work. And so we go from 0 to 2, for instance, and then 0 to 1, and then 1 to nothing, for instance. And then you want a semigroup instance for orderings. Oh yeah, because that's a Haskell historical Haskell thing right there, and we just need to do monoid is only the mapT part and semigroup is the mapN part, right? Except you want it to be in fact proper semigroup notation, and then it's all warnings. So now we reload, and then what? Do we have access to run? What do we want? DFS test. DFS test. We don't, so we need to load the GST declarative. Is that right? Or how does that work? Yeah, I don't remember. Plus M, no. Plus set, maybe set options. Set plus M blah. Like that? No. Okay. Set and set, and debugging, and type module. Yes, M. Yeah, colon M plus. Okay, colon M plus. Could not find. Okay, but that's better. Okay, really, is that a thing? It should be in here. I suppose it's not in the cabal file yet. That's the deal. Yes, it is. Okay, so can we reload? No, we can't. In fact, we probably need to exit the Nix develop shell and rerun it if we modified the cabal file. I suppose cabal REPL might have picked it up here, but yeah, better safe than sorry. Yeah, no, probably that was a little bit, that wasn't the smartest. I could probably have just cabal REPL'd again. And that's what we'll do now. Okay, it's now compiling the other thing, and then yay. And so now we should be able to do DFS tests. Yay. So it's doing a thing, and that thing is what? It's calculating this orderings, thing. It's just depending like how we visited that graph, I think. So we visited node 0, node 1, and then maybe these gray and black are pending stuff, maybe. Let's enlarge the graph to contain another link from 2 to nothing, for instance, and reload and see what that gives us. So we entered the vertices 0, then 1, then 2, and then we entered the edge 0 to 1, and then the edge 0, 1 to 2, and then there's still nothing in gray, and then we exited vertices to 1, 0. Right. So if we augment that graph with something like 0 to, like we say, 4, and then we say 0 to 3 now, and a 3 to 4, and then a 4 to nothing. Then what I would expect is that it would do 0, 1, 2, and then 2, 1, 0, and then 0, 3, 4. That's depth first search, right? But it doesn't, because it should be 1, 3 here instead. And we reload. That's right. So then it actually starts at the end, but there's a 0, 3, 4, and then 1, 2. And so it does 0, 3, 3, 4, and then 0, 1, 1, 2. And the exit order is 4, 3, 2, 1, 0. Interesting. Even though it entered in that order, it exits in what feels like a different order. I'm not sure that's right. Feels quite strange to me. So, okay. So DFS is supposed to take, yeah, it takes this graph search. So enter vertex called the first time a vertex is discovered. Enter edge, the first time an edge is discovered, before enter vertex. Gray, call when we encounter a back edge to a vertex we're still processing. I see, so if we have some loop, and then exit vertex called once, we have processed all descendants of a vertex. All descendants. I wonder if this is deterministic. And black called when we encounter a cross edge to a vertex we've already finished. A cross edge. Interesting. Okay, so let's have some kind of loop. Let's make 2 loop back to 0. Here we have a gray, because we encounter back edge to a vertex we're still processing. The 0, we're still processing 0, and we got a 2 to 0 edge, which is a back edge to 0. But a cross edge to a vertex we've already finished, that I don't know what that is. I mean, if it's not a back edge, then it must be a kind of, right, it's not a forward edge because we're already going down into it. I don't know. yeah, that doesn't define what things are going to be. It's probably DFS itself that actually implements the logic. DFS takes the graph search, which is this visitor pattern thing, and then black case color. Do vertex map white. Let's see what vertex map is. Is it property map? No. Monolithic maps. Interesting. Vertex enumerable. No. What is vertex map? It was in the first search, and vertex map. Maybe it's in the vertex class. Is it in data graph class? Yes. It is a property map. Okay. So before we get into this, run adjacency list. Takes an adjacency list and returns an array. So no, sorry. Takes an adjacency list, an array, and returns an A. And the A is the ordering. So is this specialized to adjacency list int orderings? I think it is. Adjacency list int orderings. Let's see if I do I call this F. If I say F is actually adjacency list, and then let's try and type this. So I surmise that it's adjacency list int orderings to G1, which is an array int and to orderings. And type checker seems to maybe agree, although where are these parse error? Okay, what did I do? Oh, okay, maybe where is the better way. And then expected one more argument. It's not a matrix, it's a list. And that's correct. So let's pull up the type for adjacency list. And let's also get the ask function because I want to use that one, try and use that one. Run adjacency list takes us this. Takes one of these adjacency lists of this. Yeah, the thing is like this orderings is a collection of functions, right? I mean, the type is not a collection of functions. The type is just the output of some functions. But yet, orderings, that's a bunch of functions. Because graph search is a bunch of functions, and GFS takes a graph search and then some initial vertex. What if we put 1 here? I'm still confused with this way this is built. Let's try ask. Can we ask something? Let's see. Ask test equals ask of what? It seems like if it's in the adjacency list I array I, then if we give it an array I, it's going to give us some IA. So let's give it G1. And okay. Yeah, let's hide the matrix for now. So that doesn't work. You need array in N to T. But you got adjacency list I0, did you? G1 is an array, it's not an adjacency list. So couldn't match expected type. Ask is applied to one argument, but its type has none. What? I think it means we need to run it. Run adjacency list, and that takes a graph. That's right. Yeah, so I think it is some smart math behind this. Using the A allows to do some smart things that are maybe graph shaped. So it feels also like it's somehow grounded in category theory. Like a little bit functorial in nature. And this idea here, also that looks quite a lot like what you find in how you define a constructor for free monads. Indeed, when you have one of these carrier types, you have an A in there, except for free monad, usually it's an A that's used to build up a sequence of operations. Here it might be something a little bit similar, but not that as in sequence, as in imperative sequencing, which usually free monads are. I mean, that's my intuition of them. But in this case, I think it's more to build up a computation in some sense, maybe. So let's see if we could do something with that ourselves without like the DFS stuff. Like, how would we make some I mean, I suppose something analogous to ask, but that wouldn't use ID, would use something more interesting. So we'd be doing like run adjacency list of, and indeed not DFS orderings, but something else. What would that be? Like some F. First of all, what would be the type of F? It would be adjacency list and I don't know, some A. Maybe we have to define that. Maybe we make it text or a string. Like, let's make it text. I think we have overloaded strings. And then some array I, or therefore int, and then we return some text. Would that fit as type for this? And so therefore, could we just make it return test? And would that just work? It wouldn't. The type of F is not right. It's expecting an adjacency list int A. It's not expecting anything more fancy than that. It's just that an adjacency list int A is fancy because it requires, because we don't, I don't know how we construct it, right? I think we construct it by doing something like const tests, maybe. No, so we do adjacency list of run adjacency list. I think that's completely wrong, but let's try equal const test or whatever. It's not completely wrong. It's not completely wrong at all. So here, the idea is that we receive a whole array I blah. And so how can we check that? Well, we would need to see how we deconstruct arrays. And these are constructors and these access things, right? So we could, for instance, just list the elements, right? So we have our R and we just like get LMs, and I don't know, that we just like fmap some like you know, like something like this, like show I, and we'd fmap that on LMs. Wouldn't that work? Our LMs of R. And we need to somehow concat that. Mconcat probably. Type string because of show, so we need like some packing or unpacking. Word lambda, sure, do refactoring if you want, if you can, and then no instance data string string. Yeah, are you sure? LMs R is going to be an array event. Maybe we just use like something like join. Isn't there a join? Yeah. Taking that's a variable not in scope. Doesn't this exist in the world? Like mjoin maybe? More than morphisms. No, it's just mconcat, but yeah, I'd like to have separators, but I suppose I can't have nice things, or so let's just mconcat and list events. Yeah. Oh, interesting. Right, I suppose in this case we seem to be just getting the edges or something. We get 1, 3, and then 2, and then 0, and then 4, and then nothing. So we seem to be going through all of these, but LMs, for some reason, gets us all the edges. I'm not sure why. It's not completely clear. Oh, I needed that. So that's elements and the list of elements of an array in index order. Right, I suppose given each of these, given this is then packed inside an array, it can make sense. I suppose if I do 2, 1, then I just get a different ordering. Get 1, 3, 0, and 2, 4. So it does make sense. And then what? That's arrays. Adjacency list. An adjacency list graph is different from an adjacency list. How do you build an adjacency list graph? There are a few instances for oh, right, those are just monad transformer style thingies. But then I suppose you just need to, but there's no default. There's some default for arc degrees and adjacent vertices. Source target and either adjacent vertices without edges, equal out edges, or out edges. So I'm surprised that there's no facility to actually create some of these guys. And did I see correctly? It requires then G is already a graph. But so far we haven't even created a graph. We just created an adjacency list. And we'd need a vertex map and an edge map. There is an instance for adjacency list. So we can get what's the A here? I have no idea. It's still confusing me. It's still this carrier A, I think, here. So let's see. If, well, hold on. That's not an adjacency list. An adjacency list would be something like F. That's an adjacency list. So you call this a graph, but not G1 for some reason, which is confusing. Actually, it's not exactly true. You call the adjacency list int. That's a graph for you. Which is probably even more confusing. It's not here. Why is it not here? Data graph class. Data graph class. Strangeness. Would it be in here? Maybe the graph instance, yes. And the agent instance list I. Is a graph. Okay, Haskell initial representation, final representation, encodings, basic idea, link A plus starting at the end. Basic idea, okay. Yeah, no, thank you. It's not tagless final, right? I don't think it is. Initial encoding, I think, is still the correct framing for that. Final encoding. So note that. Tagless final. Initial encoding that isn't extensible. Data term. Wrapper. That sounds like that's what it is, like a final encoding where this wrapper is an A. Okay, let's check out whether Edward Commit has written about final encoding. And it would be good if it was somewhere in School of Haskell, for instance, but I don't think that final is used in that sense here. The other place where it could be is in Bartosz's series of posts. Functorial. Oh, that's recent. I haven't seen that. Okay, F algebra. I think maybe this is final product. Finally, called the terminal final coalgebra. A draw constructor of an F coalgebra where the direction of the morphism is reversed. Algebra for given functor from a category with homomorphism, blah. Terminal object is that the trigger is called the terminal or final algebra. For every other algebra A, there is a unique homomorphism M. Makes the following diagram commute. Terminal coalgebra is a fixed point of the functor in the sense that the morphism blah is a morphism FTT. Is this an algebra? FT isomorphic to T. This all requires this recursion machinery to unpack, but I don't see any of this. I mean, okay, so maybe terminal encoding then. Haskell. No, of course. Yeah. Yeah, so that's just, I mean, it's finely tagless, and it might be a superset of this technique, but it's really hard to evaluate. Because we don't seem to have an eval. Ask isn't really an eval. Final encoding. Eval A, eval A. So that's not what we have, right? I mean, and clearly there's many indirections here that we don't have here. Yeah, and all of this is about not using generalized algebraic data types and the expression problem. I don't think that that's the same thing. There isn't a proper search for PDFs, I think. Yeah, I mean, way too much overhead there. Thanks, Sandy, but the real play use your final execution and initial one. tagless final is sucking the air. There might be another way to call this that I don't know. I mean, he says it's a not very Haskell-y API, but I don't think that that's the bit that's not very Haskell-y. I think it's the visitor pattern that maybe is not very Haskell-y. Okay, well, that's probably enough for now. I'm just going to close this by writing some notes about what we did. And so we did dynamically change an element. We did continue to work on the declarative JST API by looking at graph data structures to represent pipeline graphs. So that's what we started with, and yeah, next week I might get back to this tomorrow, I don't know, depending, and otherwise next week we'll be doing pure script or doing CUDA. I should write GStreamer here. Doing GPU programming here. So we shall see. I'll decide this on Tuesday, but thanks for watching, and I'll see you later. Bye-bye.